Hello guys, I am kalidas tapadar. Welcome to Quality and Meddling Metallurgy. Today we are discussing on welding of alloy steel. Group of steel: plain carbon steel, low carbon steel, medium carbon steel, high carbon steel. Alloy steel: micro alloy steel, alloy up to 0.25%. Low alloy steel, alloys up to 10%. High alloy steel, alloy above 10%. Selection of steel. Selection of steel production and manufacture of various products is done according to the properties required to suit working condition and the purpose they are to serve. Other considerations are weldability and the cost of fabrication. Cracks, distortion, porosity, lack of fusion and penetration are the common problem to the decided weldability. Manufacture and designation of steel. Steel is an alloy of iron and carbon. Alloying elements are added steel to improve properties. Steel are used for the manufacture of bridge, structure, buildings, railway, coach and wagons, storage tank, pipeline, pressure vessel. Welding of steel is done to join part to form the product for which knowledge of steel metallurgy is essential. Low alloy high strength steel. Such steel containing low carbon with addition titanium, niobium, chromium, tungsten in small percentage are used for manufacture of ship, bridge, cranes, pressure vessel, etc. Weldability of such steel is medium. Preheating control of current and welding speed is essential to produce a good weld. Standard. According to compositions, manufacturing process and use different standards have been formed in different countries. Some of the important standards are IS Indian Standard, BS British Standard, SAE Society of Automotive Engineers, AISI American Iron and Steel Institute, ASTM American Society for Testing and Material. Low alloy steel for cryogenic application. The terms low temperature and cryogenic may be defined as the involving temperature to -100 degree to -270 degree centigrade. This concept is applied to space application, oxygen process for steel making, chemical process industry, petrochemical industry, electronic industry, medical, food, glasses, cement industry. Property required for cryogenic applications. The properties required are tensile strength, yield strength, fatigue, toughness, low heat conductivity, low coefficient of thermal expansion, low emissivity, cleanness, specific heat capacity, electrical resistivity. Effect of nickel on low temperature properties. Nickel play a significant role in cryogenic steel. It increases the strength and toughness of the steel at low temperature. It important to notch toughness to steel reflected to the bright fracture of the low temperature. Cryogenic nickel steel normally have 2% minimum percentage nickel, and addition of each percentage increase the tensile strain 600 psi. Toughness test. Cryogenic steel must have high strength as well as high toughness value at sub-zero temperature. Izot and Charpy notch bar test conducted at a range of temperature provide data to find out such value. This test have been developed with the assumption that the energy observed by material is proportional to the notch toughness of different temperature. Charpy test. A rectangular bar with square cross section and notch specified geometry at the mid length supported near its ends is struck single blow behind the notch sufficient to break the specimen, generally by the swing of weighted pendulum. Swing of a weighted pendulum, notch toughness is then assessed by percent shear appearance of the fracture surface, energy observed, amount of lateral deformation of the compression surface behind the notch. Nickel steel. Popular varieties are 2.25% nickel, 3.3% nickel, 5 to 9% nickel. Liquefaction temperature of gases and associated material of construction. Gas. Propane minus 47.7 degrees centigrade, material 2.25% nickel steel. Carbon disulfide minus 50.2 degrees centigrade, 3.5% nickel steel. Hydrogen sulfide minus 59.5 degrees centigrade, 3.5% nickel steel. Carbon dioxide minus 78.5 degrees centigrade, 3.5% nickel steel. Acetylene minus 84 degrees centigrade, 3.5% nickel steel. Ethylene minus 103.8 degrees centigrade, 5 to 9% nickel steel. Methane minus 160 degrees centigrade, 9% nickel steel. Welding of 2.5 to 5% nickel steel. 2.25% nickel steel ASTM A203 are supplied in normalized condition. Electrode AWS E8018-C1 3.5% nickel steel ASTM 203 to 300 are supplied in normalized quench condition. Electrode AWS E8018-C2 5% nickel steel ASTM A645 are supplied in quench condition electrode, similar to being used for 9% nickel steel. Selection of electrode for fine grain and nickel steel for cryogenic service. The group contain fine grain steel and steel bearing nickel from 1 to 7%, like A333 grade to the give improved low temperature toughness. For fine grain plain carbon manganese steel, E7018-1 electrode may be used. For nickel bearing grades electrode, matching composition are used. E8018-C1 2.5% nickel, E8018-C2 3.5% nickel, E8018-C3 1% nickel, E8018-C4 1.5% nickel, E9015-C5 6.5% nickel. Welding of LNG tanks using 9% nickel steel. LNG, liquid natural gases. The percentage nickel steel are quenched and tempered steels having high strength and extreme toughness at very low operating temperature. Astrium A353 and A553 are typical grades. Both are having good notch toughness even at -196 degrees centigrade. A153 has higher yield strength, 585 neutron mm square minute as compared to A353, 515 neutron mm square minute. UTS for both is in the range of 690 to 825 neutron mm square. Welding of nickel steel. Normally for lower thickness, preheat is not recommended. With higher thickness and severe joint restraint, preheating in the range of 100 to 200 degrees centigrade employed. 9% nickel based electrodes are not suitable due to inadequate toughness in weld. AWS, ENICRA-3 or ENICR-6 are popular electrodes. Due to magnetic blow, AC welding often used. Creep resistant steel. Steel to withstand elevated temperature and high pressure application. Steel to withstand elevated temperature and high pressure application, boiler, pressure vessel and steam pipes in thermal power plant, chemical high pressure synthesis, parts in oil refineries, etc. Chrome Moly steel. Chrome Moly steel have been found to most suitable for this purpose due to their high temperature strength and oxidation resistance. Chromium from 0.5 to 9% and molybdenum from 0.5 to 1%, sometime with little vanadium are popular materials. These steels are air hardening steel. Creep resistant steel used for boiler fabrication. Oxidation and corrosion at elevated temperature. One of the simplest from the corrosion is oxidation of metal, which occur by the process of diffusion of oxygen inward and alloying elements outward. Above 3 above 535 degrees centigrade, oxidization rate of plain carbon steel increase rapidly. Addition of chromium to steel increases this resistance to oxidization by forming a tightly adhered layer of chromium-rich oxide on the surface of the metal, retarding towards diffusion of oxygen. Silicon and aluminum in steel also increase the oxidization resistance appreciably. Creep resistance. Creep is defined as the time-dependent deformation which occur after the application of load to a solid, especially at elevated temperature. Creep strength is important above the temperature range of 425 to 535 degrees centigrade and is primarily factored in determining design stress above this temperature. Creep test is carried out to determine the creep rate directly related to the applied stress and the test temperature. Creep test. In creep test, the specimen is held at constant temperature in an electric resistant heating furnace and is subject to static tensile load. The load causes the specimen to elongate it gradually, and the amount of elongation measured periodically. Amount of elongation is plotted against period of time to obtain the creep curve. One standard of creep strength is the stress to produce a creep rate of 1% per 100,000 hours. Correlation between the room temperature tensile strength and 100,000 hours rupture strength for 2.2 chrome 1 moly steel. It is denoted here. Welding of chromium moly steel. Welding of chromium moly steel. These steel are readily weldable with conventional arc welding and electroslag process. These steel are readily weldable with conventional arc welding and electroslag process. The air hardening property of the base metal and high alloy content of well metal demand correct welding procedure including preheat, post weld heat treatment, low hydrogen consumable and right weld deposit composition to prevent hedge heat affected zone and well metal cracking. Recommended preheat temperature in degree centigrade 0.5 chrome to 0. Chrome half moly, thickness 12 to 7 mm, 20, 95, 150. Right. Welding of chromium moly steel post weld heat treatment. Chromium moly weldments, especially pressure piping have to be stress relieved as required by relevant code. Welded joint in piping are given local stress relieved, while vessel and similar fabricated are wholly stress relieved. Stress relief temperature which are below critical range and result in reduced hardness and residual stress level and increased ductility of weld metal and heat affected zone heads. Post-weld heat treatment temperature chromium moly steel, stress relieving degree centigrade, 0.5 chromium, 0.5 MO, 590 to 700, 1 chrome, half moly, 590 to 700 degree centigrade, 1/4 chrome, half moly, 590 to 745 degree centigrade, 2/4 chrome, 1 MO, 780, 260, 3 chromium, 1 MO, 780 to 760, 5 chrome, half MO, 780 to 760, 7 chrome, half MO, 780 to 760, 9 chrome to 1 MO, 680 to 760. Reheat cracking. Reheat cracking occurs during stress relieving heat treatment of chromium, moly, vanadium steel having coarse grain heads. On heating, fine carbide form within the grains, making them stronger than grain GB, grain boundary before stress relieved. Cracking occurs if CS is above 0. Prevention. Control chemical composition, low restraint joint design, multipass welding and low heat input avoid grain growth. Selection of electrode for resistant steel, creep resistant steel. E7018B2L, it is called weld composition, 1/4 chrome, half moly, thin wall, A335 P11 pipe for tube, 588, like same. Development of 9 to 12 chromium creep resistant steel. Development of 9 to 12 chromium ferritic creep steel resistant steels for steam power plant application like thick section boiler component, steam line, turbine rotor, turbine casing has lead to doubling of the 105 hours creep rupture strength at 600 degrees centigrade. Achieved through minor compositional change to well established steel like the 9 chrome, 1 MO and 12 chromium molybdenum. The new alloy including the modified 9 chrome 1 MO steel P91 and the tungsten alloy 9 chrome steel E911 and P92 have recently been used in full scale in new power plant in Japan and Europe at advanced steam condition up to 30 MPa and 600 degrees centigrade. Properties of 9 to 12 chrome creep resistant steel. Low alloy, quenched steel and tempered steel. Basically, quenched steel have manganese, chromium, nickel, molybdenum and vanadium in different percentage as their alloying elements and undergo a water quenching followed by tempering heat treatment, which imparts adequate toughness coupled with strength. Used in penstock pipes, earth moving machineries, ships, submarine, offshore structure, etc. Few popular grade are ASTM 517, A533, A537, HY80, HY mean highness 80, highness 100, highness 130. Carbon level is 0.10 to 0.23%. Welding of quenched steel. Yield strength varies from 50 to 130 KSI. Ultimate tensile strength in the range of 80 to 150 KSI. Welding spec, preheat and interface temperature. To high preheat will produce over temper zone near fusion line. To low preheat will produce hard microstructure due to the fast cooling. The form of martensite. Heat input during welding to be carefully controlled. E.g. like maximum heat input for ASTM A516 grade F for 12.7 mm plate thickness is 2.76 kg joules mm and for 19 mm thick 3.9 kg joules mm. Level of hydrogen consumable A4 or less is preferred for high strength material. Popular electrode are selected from E8018G or similar class to AWS, E13018G/M class depending on strength and toughness of base metal. Electrode for high strength steel. These are low alloy thermomechanical treated steel as known as quenched steel. Developed for high strength application like penstock, welding, naval vessel, etc. Example: T1 steel, highness 80, highness 100, ASTM 570, A533, A537. Welding with matching strength E9018 GM up to E12018 GM electrode. Requirement of extra low hydrogen level electrode. Heat input must be controlled to prevent reduction in strength of hedge, heat affected zone. Thank you.